Hello students, welcome to the third part of the video lecture for first chapter of strength of material. Here in this video, we are going to explain the different types of strain produced in a body. In part 2, we are discussing that strain means deformation per unit length of the body, and it is denoted by symbol E. So, E is equal to change in length by original length. We are having different types of load applied upon the body: tensile load, compressive load and shear load are applied on the body. In case of tensile load, as shown in the figure, in case of tensile load, the length of the body increases, that is, extension takes place, while its width decreases as the dotted figure. Again, if we are going to apply the compressive load on the both ends of the rectangle, now seeing that the length of the body is shortening, while its width increases as the dotted figure. Both tensile and compressive strain are known as linear strain because they depends upon the change in length of the body. Now, mathematically, linear strain is equal to change in length by original length, that is del L by L. In case of tensile strain, we can make that expression as increase in length for original length. In case of compressive load, decrease in length to original length. Simply, EL is equal to del L by L. As in the formula, EL is equal to del L by L, both terms are related to length, so strain is unitless. Next term is our shear strain. Let us consider a body ABCD as AB is fixed and CD is free. Now we are going to apply the load P, that is, the line of action of force is parallel with the surface of the body, that is CD, due to which the body ABCD going to distort to another body, that is ABCD to ABC1D1. As shown in the animation, it is better understood that during application of load P, the body is deformed with angular deformation phi. What is shear strain? Now we know that shear strain means transverse displacement divided by distance from the AD. Means what? Simply strain means change in length by original length. Here we are seeing that change in length is known as your C to C dash or D to D dash, and original length is your AD. The AD is transversing, but the AD is deforming from AD to AD dash with a deformation phi. Now, tan phi is equal to P by B. So, P is equal to DD dash by AD. For very small angle, tan phi is equal to phi. Now, phi is equal to DD1 by AD. So, that is equal to change in length by distance from the A to D, that is h. So, shear strain is equal to del L by h. So, it is concluded that due to the shear force, the deformation takes place in the body distorted with an angle of phi. Now, this angle phi is known as your shear strain. So, shear strain is equal to change in length by original length, that is del DL divided by AD, that is equal to DL by H. Next, when we are going to apply the load along the axial direction, during that time the length of the body takes place into two different cases, that is length of the body increases in case of tensile load. In case of compressive load, the length is decreased. Now we are going to observe that what is the changes takes place in lateral direction. Lateral direction means what? Here on this figure, F is applied, two F's are applied or pulled on the both side of the cylinder. Initially it is having diameter capital D. Now when we are going to apply the load, the small cross section is causing in the cylinder. As the length increases, we are seeing that the diameter of the cylinder also decreases. So that is, diameter is your lateral dimension. So lateral dimension is nothing but, if we are going to apply the load along the x direction, now along the y direction there is also another dimension of the object, that is to be increased or decreased. From this figure it is concluded that due to application of load P, length increases and diameter decreases. So L plus del L takes place, D minus del D takes place. If you are going to calculate the lateral strain, it can be expressed as the change in diameter to original diameter of the cylinder. Now it is denoted by symbol ELA, that is del D by D, and both are diameters, hence it is unitless. In another case is that if you are going to study about rectangular bodies, in case of rectangular bodies we are having three dimensions, one is length, width and thickness. As shown in the figure, initially the length of the body is equal to capital L. The body L is applied, the length of body L is applied with P, that is tensile 1, due to which the length increases. Now L plus del L is equal to your deformed length of the body. During this increase of length of body, the width and the thickness by the depth of the body decreases. Here from the figure, L changes to L plus del L, while this time there is another direction, that is width and depth. Width decreases, depth is also decreases. Now it is concluded that for lateral strain in case of rectangular body, it is the ratio of change in width to original width and also change in depth to original depth of the body. So basically I am going to briefing that strain, there are three types of strain. One is compressive strain, tensile strain, both are known as linear strain, then shear strain, and lastly we are having lateral strain. Next, go for study about elastic limit. What do you mean by elastic limit? Elastic limit is defined as the maximum stress that a material can withstand before the permanent deformation. What does it mean? If you are going to apply the load, during that time the body deforms. For every material there is a certain limit. On that point where the body can regain its original shape and size after the removal of the load. If you are considering a rubber, then we are going to stretching the rubber. If you are removing the load upon the rubber, then it can again regain its original shape. That means the elastic behavior of the material exists before the elastic limit point. The elastic behavior is vanishes after the elastic limit point. So it is the maximum stress by maximum load that can be bear by the material without the permanent deformation after the removal of the load. So we are basically from this figure, if you are going to draw a stress strain diagram, then this H up to H, the stress varies directly proportional to strain, means how much load is applied, deformation takes place. If load is removed, then deformation disappears. After the elastic limit point, the deformation is permanent one, and that is known as plastic deformation. Before the elastic limit point, the behavior of the material is known as elastic, and the deformation is temporary. So all the materials are loaded within the elastic limit point.